I'm here with Victoria Livschitz from Grid Dynamics. Victoria, would you like to tell us a little bit about Grid Dynamics and why you're here at Waters Power today?
Certainly, Emily. Grid Dynamics is a professional services company that's focused on pretty much one thing, and that's scalability engineering, scalability of enterprise applications and infrastructures which run those. We are here because the theme of today's conference, cloud computing for financial services. And cloud computing is what our company deals with sort of day in and day out. We have several practices when it comes to scalability. Scaling applications is one part of the deal, if you will. You have to have applications that can consume as much resources as they need and then rise and fall, if you will, with the payloads and demands. But it doesn't do applications much good to go into a static, conventional deployment architectures. What we need is a combination of fluid capacity that can be used by applications on demand and applications that can take that capacity on demand and scale with their respective payloads. And so this is kind of exactly where my company fits architecturally. This is the kind of work that we're doing, so this conference is a perfect place for us to be in.
Perfect, thank you. And I understood you spoke on a panel this morning about cloud computing. What were sort of the main takeaways from that panel, do you think? What was the most interesting thing that you learned on that panel?
Well, people want to know if cloud computing is ready for prime time. They want to know what it's good for and what it's not good for today. There's a gigantic paradigm shift that's happening with respect to virtualization and utility computing, cycles on demand, and everything that goes into that. And so how mature is it, I guess, is the question that everybody's asking, and the panel was much about that. How mature is it? And it was a good cross-section of people who are using cloud computing in their large enterprises. It was a number of vendors who are building the fabrics for the cloud computing. My take may be somewhat unique from other panelists. We don't sell products. We make products work for our customers, and so we see a broad cross section of people trying to adapt cloud paradigms. So the takeaway is get on the cloud now. There are certain things that you can do today. It's a process, and it's a maturity question, and we as an industry is getting there.
Okay, and so what is the cloud not ready for? What things would you not put on the cloud at this point in time?
Well, one of the big questions is what clouds are we talking about? Because cloud is not a thing. Cloud is a concept, very much like a network. So to me, cloud is about virtualized networks and mobile portable applications. And so there are clouds that are private clouds where enterprise has a lot of control of all the moving pieces, which there is hardly anything you can't do with those. It just takes the right architecture and the right engineering. On the other hand, when we talk about public clouds, there's a lot of constraints that come with that because it's in many ways sort of lowest common denominator. So if we talk about public clouds, things that are very good for our shared nothing architectures, things that can afford not super low latencies, but sort of eventual consistency and mid-grade latencies, things that are not terribly depending on proprietary, secure, and internal data. Specifically for Wall Street, things that are related to batch processing, things that are related to Monte Carlo simulations, and everything related to testing and QA environments are where we see a lot of early adopters.
Okay. And one last question. How is cloud computing different to grid computing?
Oh, well, there's a loaded term or a loaded question. I don't know if they are. Grid is also a concept, and a cloud is a concept. The notion behind the grid is that you can make many individual nodes work together as one. And notion of a cloud, to me, is largely about not caring where stuff happens. So it's about levels of abstraction, and it's about virtualization. Other than that, what we are talking about in all of this context is that how do you make massively parallel, massively distributed computing infrastructures work for applications? And in that sense, they're both grid computing, cloud computing is kind of in the same bucket. You could look at it a little more technically and say grid computing is about high-performance computing, cloud computing is a deployment paradigm, and a lot of projects that my firm does and a lot of things that our customers do is actually figuring out how to deploy grids on clouds. And that's another legitimate way to think about it.
All right, Victoria Livschitz, thank you very much for your time.